and today I'm going to be giving you a little overview of how you can work with JSON data inside of Pandas. So some assumptions and disclaimers I'd like to make about this video up front is I assume that you have some programming experience, be it with Python, Python and Pandas, or some other programming language. I will, however, be focusing on explaining things rather than aiming for engineering excellence. So if you are an experienced data engineer or software developer, some of the ways that I'm doing things may not necessarily gel or certainly won't scale to production type loads. My goal here is to explain things. So who am I? My name's Ryan Collingwood. I've worked in a variety of roles within the IT space as a business analyst, as a software engineer, as a data analyst, and as a product manager more recently. So let's first do a quick recap on data structures. So the first data structure I'd like to introduce you to is a list. And a list is just quite simply a list, as you expect, like a grocery list. You have multiple things inside of this one container. And what we have on screen here is an example of how you would declare a list in Python. And what a list is good for? Well, they're good for storing multiple values. And the way that you access things inside of your list is based on the index, that is the position. And Python being a zero-based index language, the first item in our list is at index 0. If you're coming from, say, R, which is one-based index, the first item in your list is at index 1. Okay. So then let's talk about another data structure called dictionaries. So dictionary is a key value pair mapping. So what do I mean by that? Well, in these key value pairs, as we see over here, we've got some attributes about the item of interest. So in this case, we have a grocery dictionary, which has the details about a particular item. And that item is apples, and it has a unit, which is kilograms, a price per unit, and a price currency. And the way that we access the individual items of interest, we use key-based patterns to access it. So for instance, if I wanted to get the unit that exists in this dictionary, I would access it by using the text unit rather than a number. So combining these things together, dictionaries and lists, we can create complex data structures. So for instance, what I have here is a list of dictionaries. So that is a list that contains dictionaries. And within those dictionaries, I have key value pairs detailing data about the items in my grocery list. Similarly, I could have a dictionary of lists. So what I have here is a number of keys, items, units, price per unit, price currency. And what you'll see is that at index 0 for each of my keys, I have the information for apples. At index 1, I have the information for bananas. And this is another way that we can represent complex data structures. So let's quickly talk about JavaScript object notation, or otherwise referred to as JSON. Let's look at an example. JSON is a popular data exchange and representation format. Okay? It uses text to store and transmit data objects consisting of attribute value pairs and arrays. So a moment ago, you heard me say lists. In the JavaScript world, that list structure is referred to as an array, as well as a number of other programming languages. And that attribute value, that in the Python world is referred to as a dictionary. So across different programming languages, these concepts have similar yet different names. So let's talk about the pros and cons of JSON. The pros are you're able to store and transmit records that have varying data structures, and it's also very human readable. And one of the cons is that analysis and querying tools tend to not like records that have varying structures. They want to have data that looks more akin to a grid. So how can we take JSON data and put it into a format that analytical tools will play nicer with? Well, within the Pandas world, there is a function called JSON normalize. So here's a snippet of Python code. And what I've done is I've imported the JSON module as well as the Pandas module. And then I have this variable called data, which is a string. So that's just a blob of text that matches a JSON structure. You'll see that I have effectively in JSON terms, an array of attribute value pairs. So in order to read into this data, what I'm going to do in Python is load it from my textual structure into memory. So I'm going to parse it, okay? And when I do that, you'll see that I now have a effectively a list of items. And that first item on my list is a dictionary, that key value pair situation. Now, if I wanted to take that and convert it into a grid-like structure, I can use the JSON normalize function from Pandas. Over here, I've done just that, and you'll see that now I get a data frame. So that's all very well and fine for a very simple data structure. But if we're dealing with a slightly more complex data structure, you know, how do we handle these complex nested structures? Well, I've put together a collaboratory notebook. So collaboratory is a interactive programming environment, typically used for data analysis and exploration. I've created a notebook there that you can go and look at yourself and run. And I'll just be talking to what I did in that notebook. So within that notebook, there's a couple of modules that we'll be using. We'll be using the glob module for finding files that we want to put together and work with, JSON for reading in the data, and then pandas for doing the data wrangling. So let me talk to what the example is. So this example in my notebook is some mock data around a social network. And there are multiple JSON files contained within a subfolder called data. So what I'm wanting to do is first parse those JSON files, okay, so read them into memory, and then convert them into Pandas DataFrames, and then potentially join them all together. So let's again look at the case of reading in some JSON data from our hard drive. So what I've done here is I've accessed the first .json file on my hard drive. Okay, so I've opened that up. I've read the contents into memory, so that's what file contents is. And then I'm going to parse those contents as JSON data. So that's JSON.loads, and then I'm assigning that into the variable called JSON underscore data. And then I want to get it back as a pandas data frame, so that's my grid table structure. And I say PD JSON normalize, and I get back a new data frame. So when I have a look at this new data frame, what I get back is this singular row that's really, really, really long. Okay. So what's going on here? So looking at the columns, we've got the metadata columns coming through, and then this one column from data that seems to have the bulk of the information stored therein. And if we go back and look at the example, all right, you'll see that the metadata information is listed, and then the data, which actually contains the records, is the sort of the second key in the hierarchy that we're having displayed on here. So we actually want to get the information from that second key, the data key. So how do we tell JSON normalize to grab it from that point? Well, we can pass in an optional parameter. Okay? By specifying the record path, we tell JSON normalize where to start reading in the data, and from which point in the document we want to parse in the information and create our tabular structure. And as we can see, when we just look at the first row, we now have a much more compact data structure with our actual rows there. Okay, so we've managed to read in one document. Let's go back to that case of we've got multiple JSON documents that we want to read in. Well, this is where the glob module comes in. So glob allows us to find files on our hard drive based on a certain pattern. So what I've told glob over there is to go look in the data subfolder and then go match all files that have the .json extension. So that asterisk character there, or star, that says match anything. Okay, so as long as the file name ends in a .json, it'll match into this glob pattern that I've asked it to go and find. And as you'll see, I've told it to output the results, and we've got all of my JSON files over there, which matches that folder structure that I demonstrated earlier on. So how can we combine these multiple JSON documents that we're going to parse and then put into a pandas data frame into a single data frame? Well, one approach is to have a list, and then into that list, we will append each one of our new data frames. Okay, so that's what I'm doing over here, is that I'm iterating over that list of JSON files that I found. I'm opening up each one of those individual files. I'm reading it into memory. I'm parsing it as an object that matches the JSON structure. And then I am passing that to pandas JSON normalized to get back a data frame. And then I'm adding that data frame to my list called loaded DFs. So if I have a look at the type of loaded DFs is in fact a list. And if I have a look at the type of the first item in my loaded DFs, a list, it gives me back a pandas data frame. So what I have now is a list of data frames. Cool. But how do we put them all together? Well, within the pandas module, there is a concat function, which quite simply will take a list or an iterable of data frames and stick them all together. And now, if I have a look at the shape, so that's how many records and how many columns, I get back 2,000 rows and 103 columns. That's a lot of columns. Let's go have a look at that. So let's inspect the column names. if you remember our JSON structure, which I've sort of represented over here, we had this data key, and then that had a array or a list, and then within that we had a number of tags. Okay, so we had a very nested structure going on here. And so what we'll see is that if we have a look at the data types in my resulting data frame, you see that we have this format here of tags dot hashtag music dot liked, tags dot happy dot liked, right? So what it's done is that it is flattened out that nested structure and it's representing that in the names of the columns that we have. So these column names, while they are helpful for us tracing back the lineage of the data, may not necessarily be very easy for us to work with in our flat analytical world. So one thing we could do is rename the columns. Okay, so what I've done here is I've just generated, looking at the existing columns, replacing some characters, and then generated some new column names. So that makes it a bit easier for our purposes right now. So let's talk a bit about dealing with nested values. So at the moment in our data set, we've got this friends column. Okay? And this friends column actually contains lists. Okay, so we have nested data inside. And this what makes us sad because this is very difficult for doing analytical workloads. So to get a bit theoretical for a second, so Hadley Wickham, who's a prolific author within the R data science world, put forward this notion of tidy data. So tidy data is a standard way of mapping the meaning of a data set to its structure. And there's sort of three heuristics around tidy data. So in tidy data, each variable forms a column, each observation forms a row, and each cell is a single measurement. And it is that third axiom that we've kind of violated here with our current data set. So have a look at this blog post where I pulled this image from. It explains tiny data, really great, lots of great visualizations. So what we want to do is take this column that contains a list, the singular column, and explode it into multiple columns. A way that we can do that is by applying the Pandas series function to that particular column. So what you'll see here is I've taken the first three rows from my friends column, and I've applied the series Pandas series function to it, and now I get back multiple columns. So we exploded it out. Okay, and comparing what we started with, on the right-hand side, and then what we've landed up with on the left-hand side. So something that has been lost here is that we've kind of lost the ID of our initial column. Now, this isn't necessarily a deal breaker because we still have the built-in index on the side, so 0, 1, 2. But if we wanted to keep the ID, so the actual ID from our dataset, one approach we could take is to set the, say, df.setIndex to ID, and then select the friends column, and then apply pd.series. So what we get back here is just the IDs from the original dataset with our now exploded columns, right? Contrast that where previously we hadn't set the ID and we just worked with the original automatic index. It just helps us understand this singular dataset, this exploded dataset, a bit more. Having that ID present just gives us a bit more context. So another thing you may observe now is the column names aren't particularly great. The column names quite literally just map to what index a particular value was at. So 0, 1, 2, 3, 4. So one thing that we could do is just give it some better column names, right? So what I've done here, again, using a list comprehension, is just generated some more meaningful columns. So friend 1, 2, 3, 4, and then that'll proceed to however many columns were exploded out. So what we have now is a grid data structure that is better suited for complying with the rules of tidy data. However, we still have some challenges because querying this wide data frame is really, really difficult. So if I wanted to find out, all the IDs that had a relationship with the friend with an ID of 200, I'm going to have to query every single column, right? And in this case, you'll see that I've just queried the first 6 and then just kind of given up. It's just too difficult. It's too laborious. There's a whole bunch of copy pasting. And the more you copy paste, the more likely you are to make a mistake. One approach we can take is to melt the data frame. So what melting does is that it'll take a wide data frame and convert it into a narrow data frame. So within the Pandas module on a data frame, we can call .melt, all right? And what that does is it takes this wide data frame and gives us a long data frame. So what we have now is where we had individual column names, all right, what we have now is those column names are transposed into a column called variable. Okay, so frame 1, 2, 3, 4, 5, 6, 7, 8 is now contained within a column called variable. And the value that was in that corresponding column is in a new column called value, right? So we've taken this one very wide row and made it one long shape. Okay, so that's what it means by melting. So at this point, I'm going to move a little bit faster. So we're going to put it all together. So how did we deal with nested values? Well, what we did is we applied the Pandas series function to a column called friends that had lists inside of it. We then melted it, okay? And in melting, we'll get a lot of empty values. So that's what drop NA is doing. And then what I'm going to land up with is a column that would be familiar to any of you that have worked with sort of like a relational database. And I have effectively this mapping data frame that it tells me that from ID 1, there is a relationship to ID 1210, and so on and so forth. So now that we have this mapping table, we can start merging or joining data frames together. Okay. So in the Pandas world, this is referred to as merging, but if you come from a SQL world, you probably know this more as joining. Now, the topic of joining itself is something that merits a lot more attention. Here's a great article that you can look at from RealPython that talks about pandas, merge, join, and concat. These are all ways that we can sort of smash data sets together. Earlier on, we had a look at concat, but this article goes into a lot more detail, particularly around using merges and then joins within pandas. So let's have a look at an example of merging a data frame. So over here, I've got my friends' IDs. So that's that mapping that I had, all right? And what I'm going to do is I'm going to bring in my original data frame, okay? And I'm only going to bring in the ID, the tags amazing liked, the tags amazing posted columns, right? And those next two parameters, left on, right on, tells Pandas how to match, how to stitch these two data frames together. So left on, which is going to refer to my friends' IDs, okay, I'm going to tell it to look at the from column. And then right on, which is going to refer to my data frame called df there, is on ID. So that's how it's going to join these two disparate data frames together. So what I land up with now is a new data frame where I have from to, all right, and the tags amazing likes and the tags amazing posted are the tags amazing liked and posted for the from person, okay, as it was in my original data frame. All right. Another way that I could do this is I could repeat the same thing and perhaps just drop the rows that have empty values, and then do some other stylistic choices, like filling in other empty values with 0. So let's take this a step further. So some more joining. Again, I am now going to create a data frame called from interactions. All right, so I'm going to merge, like I did before, my friends mapping, friends IDF data frame with the columns from my original data frame, and then store that in a data frame called from interactions. Okay, so what I have here is the details about the from side of this relationship. Okay, so the person with ID 1 liked the amazing tags 0 times and posted about it 0 times. And what I'm going to do next is I'm going to create a to data frame. Okay, so instead of matching on the from column on left on, I'm going to match on the to column. So now I have these two data frames, which I can then merge together. Okay, so there's my from and my to, and I'm going to bring them together. And what I have now is for each relationship, I'm going to have details for the from person and the to person, their interactions with the amazing hashtag. But looking at these column names, what's up with underscore X and underscore Y? Well, because my two data frames have overlapping column names, okay, by default, Pandas will append X and then underscore X and underscore Y for the left and right data frames respectively. So what I can do instead when I call merge is to specify the suffixes. So in this case, for the left data frame, it's going to append underscore from, and then on the right data frame, it's going to append underscore to. So what I land up with then is a data frame where the column names make a little bit more sense. Okay. So you can see over there that was the suffixes parameter that we specified. So now that we have this data frame that tells us about the relationships between two people and their interactions on a particular hashtag, we can start doing some analysis. So a question that we might be looking at here is, of the people being followed to, who is the most influential? Influence being the most number of followers and how prolific they are as a poster in the tag. So doing a bit of jumping forward here, I'll happily make another video sort of explaining aggregations, because again, that is another whole topic unto itself. But basically, taking the learning that we've had in this explainer about reading the data, working with nested data, melting it, restructuring it, we're able to get a data frame that allows us to plot this information, right? So we can now see that, for instance, Carrie Peterson has as many followers as they have total number of posts. Whereas if we go a bit further down, we'll see that Timothy Hayden posts a lot about the amazing tag, but has fewer followers. So perhaps our hypothesis here is that there are some people who, for very little effort, are able to attract a lot more followers versus other people who put in a lot more effort and are not able to attract as many followers. So thank you for your time. This has been a brief and quick explainer about how to work with JSON data using Pandas and Python. Thank you for your time. If you want to reach out to me, I'm available on LinkedIn, on GitHub, or on Twitter. And if you have any questions about working with data or doing things inside of Python, I'd love to hear them. And take care.